So we're going to use some of our properties of radicals in this next section when we're adding and subtracting radicals. This is very, very similar to when we added and subtracted like terms, because what we're going to do with radicals, we can only add and subtract like radicals. So what that means, if you look here at the bottom, these both have a square root of 2. You have 5 square root of 2 plus 7 square root of 2. That's a like radical, which means what we end up doing, we actually leave the square root of 2 alone, right? Imagine that was 5x squared plus 7x squared. Well, we wouldn't do anything with the x squared. That just tells us that we can add 5 plus 7, which is 12x squared, right? So this time, we leave the square root of 2 alone, but we can add the 5 plus 7, which is 12 square root of 2. So you look at number 2, there's no number in front of that 6, right? Just in case you forget, that's almost like saying a 1, right? So if you want to think about this, again, this is almost like saying x to the 6th minus 3x squared plus 4x to the 6th. Well, that x squared, there's nothing you can do with that. We don't have a like term to that, but we do have the x to the 6th and the 4x to the 6th we combine. So we look at the radicals in a lot of the same light. We can do this 1 square root of 6 and the 4 square root of 6 means that we have 5 square root of 6 minus 3 square root of 2. And since the square root of 6 and square root of 2, pretend like that's these x squares and x to the 6. You can't combine them, which means there's our final answer. So this is where it's going to come full circle with the stuff we've been doing for a couple days. Sometimes you have to simplify the radicals first, and then we can combine like radicals. So initially, number 3, square root of 12, square root of 48, square root of 27, those are not the same. That's like x to the 12th, x to the 48, x to the 27th. But here's where the radicals are a little bit different than what we saw before. If we simplify them, right? So in other words, let's do what we've been doing the past few days. There's 4 and 3, 2 and 2, which means 2 can break out, and we're left with square root of 3. The 48, that's the same thing as 4 times 12. So we have 2 times 2, 4 times 3. We have 2 times 2 again. So 2 sets of 2 can break out, which means we get a 2 times 2 on the outside and 3 stuck on the inside. So in other words, 4 square root of 3. And then finally, square root of 27, that's 9 times 3. There's 3, 3. So this time, a group of 3's can break out, which leave us with 1 behind. So 3 square root of 3. So in other words, this is now turned into, right, 2 square root of 3 plus 4 square root of 3. And then you can see that minus, we're going to bring that down, minus 3 square root of 3. So in other words, 2 plus 4 is 6, right? So we combine all of our, or we simplify them all. And then all of a sudden we see, hey, these all have square root of 3. So what's 2 plus 4? That's 6 minus 3. So my final answer is 3 square root of 3. So again, what we've done is we simplified each radical, and then we'll just go ahead and add them like we did at the beginning of this page. Right? So you can see there's all the simplified versions. I put them all in the same box down here at the bottom so I can combine like radicals. Number 4, you cannot do anything with square root of 3, but square root of 72, well, 72 is 9 times 8, which will be 3 times 3, and 4 times 2, which will break down into 2 and 2. So I'll just go ahead and bring that square root of 3 all the way to the bottom. So now all of a sudden, square root of 72, we can break a 3 out of jail. We can break a 2 out of jail. So we break a 3 and a 2 out. That'll mean 3 times 2, and then this 2 is left behind. So this will end up being 6, square root of 2, 128. Let's see, 128. We can divide by 4. There's 4 and 32, which means we have 2 and 2. This will be 16 times 2, which is 4 and 4. So here we go. We've got a group of 2's that can break out. We've got a group of 4's that can break out. So we have a 2 and a 4 that get out, and a 2 that's left behind. So what we end up with at the end of this one would be 8 square root of 2. And then finally this 108. Let's think about 108. I'm going to slide them over here. Again, I believe 108 is divisible by 4, so we have 4 times 27. So we end up with 2, 2, So you have a 9 times a 3, which would be a 3 and a 3. So this time a 2 can break out and a 3 can break out. So we have a 2 and a 3 that break out and a 3 that's left behind. So in other words, now this will turn into plus 6 square root of 3. And if you look carefully, we've got a couple of like radicals. You got 1 square root of 3 plus 6 square root of 3. And that'll be 7 square root of 3. And then 6 square root of 2 plus 8 square root of 2 will be, oh, excuse me, actually, that's supposed to be minus 8 square root of 2. If you look right there, my apologies. So 6 minus 8 is actually negative 2 square root of 2. And that's as far as it'll go. Do one more in this video, just to kind of give you one more look at it. Again, square root of 20 is not one that we know, so let's break it down. Square root of 20 is 4 times 5. We'll break 4 down, that's 2 times 2. So there's, the 2's can bust out of there. There's already a 2 on the outside. So those 2's make a break for it. The 5 is left behind. The square root of 3, nothing we can do with that. And then 27 is 9 times 3. Again, 3 times 3, which means a 3 is going to break out. There's already a 2 out there, so we got a 2. The 3 is already going to join the 2, excuse me, and then one of the 3's got left behind. So let's clean this up a little bit. So we end up with 4 square root of 5 minus square root of 3 minus 6 square root of 3. And here we are. Here's a set of like radicals. So that's like saying negative 1 minus 6. So we end up with 4 square root of 5. And then that'll be minus 7 square root of 3. Again, they have to have the same number under the radical to combine them. And every so often, what we can do, and this is probably going to be more the case than not, you have to simplify the radicals, and then you're going to see that there are probably some like radicals in there somewhere. And just for the sake of completion on this page, let's go ahead and finish this one out. So 8, we have 4 times 2, 2 times 2, which means set of 2's break out. So they already got a negative 2 out there. Another 2 is going to join them. A 2 got left behind. 45, that's 5 times 9. We got 3, 3. So this time, 3's are going to make a break for it. There's already a 3 out there. A 5 gets left behind. And then here we are with square root of 8 again. So that's 2 times 4, 2 times 2. So here we go. A couple of 2's make a break. There's already a 2 out there. So one of the 2's will join them. One got shot, unfortunately. And then a 2 got left in jail. So let's kind of clean it up. So we got negative 4 square root of 2 plus 9 square root of 5 plus 4 square root of 2. Again, if you want to think about it this way, imagine this is negative 4x squared, and right, plus 9x to the 5th plus 4. Let me clean that up just a little bit. So negative 4x squared plus 9x to the 5th. So I'm just pretending like that square root of 5 is like x to the 5th. And the square root of 2 is like x squared, right? So you think about it, the like terms here, we can't do anything with that 5. It doesn't have a buddy, but we do have a negative 4 square root of 2 plus 4 square root of 2. Well, strangely enough, that's going to be 0 square root of 2. So at the end of the day, all I'm left with in number 6 is 9 square root of 5.